So here's my edited design. Um, One thing that I did, so basically here is our MOSFET. I got a little creative with the heatsink for the MOSFET. I just soldered the O-ring connector because I didn't have any heatsinks lying around. But I mean, it does the job. Here's the inductor. These are our capacitor banks. This is the load. Here's the diode, and here's our input side and the driver circuitry. The Arduino is not connected to anything. The gate, the driver circuit is driven by my signal generator with this thing. But the main edits that I did was I reduced the size of this inductor. So from 460 microhenry, I reduced it to, so the nameplate of this is 100 microhenry inductor, but measured inductance shows 220 microhenry, I think. Yeah, and then I significantly increased the capacitors at the output to account for all that extra delta I from the inductor. In terms of layout, I tried to keep this loop as small as possible to decrease any electromagnetic interference. I also included this capacitor at the input because my power supply was a little bit struggling to supply that much current at the same instantaneously. So I put this charge bucket with I think 10k resistor at the bottom, so it can discharge over time. But yeah, the layout is very simple. This entire thing, these are 50 ohm resistors connected in parallel and then connected in series to this half ohm resistor. I originally wanted to use this as a sense resistor, but I realized that it does not make sense to have a sense resistor in series with the load for a buck converter, because it's much better to have a shunt voltage divider across the output terminals. So for now I just consider that as part of load because it does not make sense to put a series sense resistor in there. And as I was working with the circuitry, I realized there are some issues with the drive stage, with the gate drive for the MOSFET, and I will try to figure it out. But here are the numbers and overall performance of the buck converter. I have connected this power supply. It supplies 32 volt max. I originally planned to use 36 volt because I thought the maximum voltage of this power supply is 36 volt, but it turns out it's 32. So I made some adjustments to my drive. Yeah, the control of the gate of the drive circuitry is done with that function generator, and the oscilloscope is connected at the output, so across the resistors. Let's see. Oops. Sometimes it happens. Okay, so at 32 volt it is giving me 1.467 milliamp, and look at that noise, but it's giving me an average of 23.9 volts DC. With all that noise, I'll need to account for that. Let's take a look. It is mostly ringing. Oops. I need to account for this ringing. It actually was much worse, but then I added this ceramic capacitor here. I think without this ceramic capacitor, there is a significant ESR across this electrolytic capacitors. So this one helped a little bit. However, still you can see that there's a lot of ringing. The usual way how it can be addressed is to add a snubber across this diode, so it acts like a damper for this ringing that is occurring in this loop, but it will take a little more time. I don't think that I'll be able to finish it, by tomorrow. But yeah, I'll send the updated circuit and all the mistakes that I found out along the way, and also include all this efficiency calculations. I think it was more than 90%. I'll include the calculations.